Okay, this first one is a pretty straightforward application of the chain rule. The inside function, the outside function is the power function to the ninth power, so we're going to differentiate by bringing the power down, leave the inside alone, times the derivative of the inside. Not much left to do there. Another chain rule. Derivative of secant is secant times tangent. Leave the 4 alone. Derivative of secant is secant times tangent. And then we have to multiply by the derivative of the inside. So the inside here is 5t. Derivative of 5t is 5. Chain rule. Leave the inside alone. Multiply by the derivative of the inside. This next one's just a trick. Right, x to the e, that means x to a power. E is just any other number, so we're going to bring the exponent to the front and reduce the exponent by 1. That's how we differentiate a power function. Derivative of e to the x is e to the x. This next one is the simplification part that usually gets people. I prefer to use the product rule here. Many of you like to use the product rule by bringing the 2t minus 3 squared upstairs is 2t minus 3 to the minus 2. That's fine. And similar algebra will get you simplified there. I'm going to use the quotient rule. Starting with low, d high, minus high, d low. Right. So the derivative of the low is 2, leave the inside alone to the 1 times the derivative of the inside. All over low squared. Since this is already squared and we square it, we'll have the 4th power there. What is simplification here? We want to take these derivatives later and we want to be able to determine whether they're positive, negative, and 0. That means we have to have this in a factored form. Okay, so we're going to factor out what we can from the numerator. Factor out what we can from the denominator, or from the second term. So we took out the 2t minus 3, so we have 4 left behind. And then 5t cubed minus 6t. Can cancel one of these 2t minus 3's here. That's cubed. If you multiply out the stuff here in the numerator, it takes a step or two, but you should get. And if I could, I'd want to factor this cubic polynomial, but it's not clear, at least right now, without looking a little harder, how to do that. What I don't want to do is expand the numerator here. I'm going to pause for a moment and adjust the camera. Don't expand the numerator or denominator. If you do that, you're just going to make a mess out of that, and it makes it even harder to determine where the derivative here is greater than 0, less than 0, or not equal to 0. Similarly, don't expand it here in the beginning. It's just going to make a mess. Use the chain rule on that piece. Okay. Similar things happen on this next problem. I have here x cubed times x cubed plus 2x to the 1/2. Product rule. Leave the first alone, differentiate the second, which is a chain rule. Multiply by the derivative of the inside, plus, that's from the product rule. Differentiate the first, leave the second alone. Again, I want to factor out common terms. Okay, and here I'm going to factor out some x cubed plus 2x since it's in both places. And the amount we factor out is the smaller exponent, minus 1/2 or plus 1/2. We're going to factor out minus 1/2. I also see here that I've got an x squared on each term, so let's go ahead and factor that out. Okay, in this first term, I have a 1/2 x remaining. This is all still there. 3x squared plus 2. Plus, we took out the x squared, but we didn't take out the 3. We took out minus 1/2 power of this term, so we have to leave some behind. And that's going to be the first power, because if I take first power times minus 1/2 power, I add the exponents and I get plus 1/2 to get back to where I started. Now I'm going to clean up the bit inside the brackets here. And after a step or two, you should get 9/2 x cubed plus 7x. Alright, that's just from expanding out these terms inside the brackets. And this is a perfectly good answer, although negative exponents are sometimes confusing, so maybe we want to write this as x squared 9/2 x cubed plus 7x. Now some of you will have factored a 1/2 out of in the numerator here as well, and it doesn't really matter. Our main point is to be able to look at this and determine where the derivative is 0, so the factors. We could take an x out of here, but factoring out a constant is usually not very important. Right. This next problem is quite a lot simpler if you use properties of logs before you differentiate. Log base 5 of 25 is 2. This exponent here can come to the front. And now the derivative is a lot simpler. Derivative of 2 is 0. Leave this 2 alone, times the derivative of log base 5 of x, which is 1 over x natural log 5. Done. Next one is quite a lot simpler if you do a little algebra first. This is the cube root of x squared, or it's the cube root of x and then square. It doesn't actually matter. Either way, you're going to get here, or maybe you have x squared to the 1/3, but in both cases, that's x to the 2/3 plus 6x to the minus 1/2 power. We haven't done the derivative step yet, so here we go. Many of you kind of use the chain rule here, and it will work, but it's messier. All right, bring the minus 1/2 to the front. It multiplies that minus 6, or that plus 6, and becomes negative 3. And there's our answer. Okay, this next one is an application of the chain rule. It's actually a double chain rule, but we have to be careful. 9, leave what's on the inside alone to the 8th. Multiply by the derivative of the inside. Derivative of x squared is 2x. The derivative of 2x plus 5 to the 7th, well, that's another chain rule problem. Times the derivative of the inside, which is 2. Right. A number, you want to take this 2 out here and put it outside these parentheses. All right, but it doesn't multiply everything. It only multiplies the derivative of the second term. So be careful there. I'm going to start with the outside function. This is cosine of some stuff, so the derivative of cosine of some stuff is minus sine of the stuff times the derivative of the inside. derivative sine of some stuff is cosine of the stuff times the derivative of the inside, 2t. So it's a double chain rule. If you're using the product rule on this next problem, you're working way too hard. All right, because if you're going to simplify, if you're going to do the product rule, it's a mess. You have a lot of fractional exponents. Okay, and then you're still going to have to deal with the fractional exponents after you've done the derivative. Why not deal with the fractional exponents right up front? So I'm going to distribute that t to the 1/3 onto both pieces. When the bases are the same, I add the exponents. So I get t to the 3/3, or just t to the 1, or just t. And this is t to the 0, which is the same as 1. So this function is t minus 1. So its derivative is the derivative of t minus 1, which is 1. Done. Similarly, this next one, if you started doing the chain rule here, it was a mess. Right? Better to do things up front. This is x to the 1/2 to the 1/2 to the 1/2. When I raise a power to a power, I multiply the exponents. So this is simply x to the 1/8. 1/2 times 1/2 times 1/2. The derivative. And now it's just a simple power rule. Always look for things you can do up front before you differentiate. Likewise, this next one. This notation sine squared of t is unfortunate, but this is the same thing. That's what we're stuck with. Properties of log says I can bring that 2 to the front. Now I'm going to differentiate. So 2, pull that out of the way. Derivative of natural log of sine t is 1 over the inside times the derivative of the inside. You can leave it like that, or you can write this as 2 cotangent of t. The next one is just a straightforward application of the product rule. See if you know what's going on. Derivative low d high, derivative of natural log of t is 1 over t minus high d low over low squared. Now there are some simplifications you can make there, but it's not important on this problem. This last one is our implicit differentiation. When I start differentiating everything by x, this is telling me I want the derivative of y with respect to x, so I'm going to take the derivative where x is the variable and y is a function of x. I need a product rule here, I need a product rule here. X squared times the derivative of cosine of y is minus sine of y times the derivative of the inside dy dx plus x 2x times the derivative of cosine. I said that wrong. Here we're using the product rule, so we're going to leave the first alone, differentiate the second. Differentiate the first, leave the second alone. Derivative of sine 2y is cosine of 2y times the derivative of the inside 2 dy dx. Okay. Similarly on the other side here, a product rule, x times the derivative of y dy dx. Plus leave the y alone times the derivative of x, which is 1, so we'll just leave the y. Right. Now I have 3 terms here that have dy dx's in them. I'm going to move those all to one side. This guy. And this guy. So I subtract it over here. Likewise, all the terms without dy dx's, we move to the other side of the equation. We factor out the dy dx on the left side and then divide by the coefficient of dy dx to get Now I made the choice to move the dy dx terms to the left and the other terms to the right. If you switch it around, you're going to get the same answer. It'll look a little different, but if you factor a negative out of the top and the bottom, you'll see that your answer and this answer are identical.